Hello, welcome. I am Quentin Austin. I will be presenting to you an overview of polystyrene and SBS rubber. Let's discuss the overview of what we will be talking about today. It will cover what is polystyrene, who discovered it, and when it was discovered, why is it so important, and why am I presenting about it if it's so important. Applications of polystyrene products, discussing one of its copolymers, SBS rubber, the current research being done on polystyrene, and then lastly we will conclude our presentation and discuss prospective research in the future. So firstly, let us ask, what is polystyrene? Polystyrene is a large commodity thermoplastic derived from the styrene monomer as shown in figure 2. Polystyrene has great processability, making it easy to create a wide range of products, as we'll discuss in applications. However, majority of polystyrene production is of foams, films, and sheets of material. Polystyrene is an amorphous polymer, which means it has 0% crystallinity. This plays a role with its glass transition temperature of 100 degrees Celsius. Once it passes 100 degrees Celsius, it softens quite easily. Polystyrene also has a high refractive index of 1.592, which is very similar to that of glass, ranging from 1.5 to 1.65. These properties will be further discussed in applications. Moving on, we need to ask ourselves, who discovered polystyrene? Well, conveniently enough, the story behind its creation is really quite interesting. Polystyrene was originally discovered by a German chemist in 1839 by the name of Eduard Simon by distilling and isolating the polystyrene monomer from natural resin from a sweet gum tree. Simon had no idea what he had discovered on accident and did not research it any further. It actually took nearly a century later, in 1922, for another German organic chemist by the name of Hermann Staudinger to publish a theory on these findings. Later, for his research and efforts, in 1953, Staudinger was awarded the Nobel Prize in Chemistry. And then in 1930, Bashdish Aniline and Soda Fabric, or BASF, developed the first commercialized method of producing polystyrene. Shortly after, in 1938, the Dow Chemical Company introduced polystyrene to the United States market. Probably my favorite fact about the development of polystyrene was in the early 1940s, a man named Ray McIntyre, who's actually from a small town of Gardner, Kansas, accidentally invented polystyrene foam while searching for a good electrical insulator material. Moving on, we must raise the question as to why the styrene family is so important. Obviously it has to be important for Staudinger to be awarded the Nobel Prize in Chemistry for its development, right? Well, polystyrene is the second most common polymer material in the world, trailing closely behind polyethylene. Since its development, there has been such a vast array of products that have been developed from polystyrene. In 2010, the Dow Chemical Company produced 22 trillion 5 billion pounds of polystyrene alone. It is one of the largest volume commodity plastics, comprising approximately 7% of the total thermoplastic market. Polystyrene's ability to copolymerize has really broadened its application in numerous ways. Below is the chemical structure of SBS rubber, which is styrene monomer bonded to a butadiene, then bonded to styrene again, hence SBS. And this is very common with many of the other styrene block copolymer derivatives, and this ties directly into our next slide, applications. As you can clearly see from the range of polystyrene's products has seemingly no limits. Of course it would seem that way, from car interiors, bowls and food packaging, from packing peanuts to spray foam insulation. It's no wonder that it's the second most common plastic of an average household. Well, with all these applications, what would there be more to research? Well, moving on. Current research of polystyrene consists predominantly of better improving the overall flame resistance of the material, as well as better enhancing the UV resistance of these materials. Of course, with the push for greener plastics, more research is being done on ways to put fillers or additives into the polymer to somehow allow it to biodegrade and be healthy for the environment. Styrene has a benzene group within it and is considered carcinogenic, making it not very suitable for the environment. In conclusion, there is still plenty of research left to be done for polystyrene. I feel that further research into additives and fillers are the key to better enhancing this commodity plastic into potential engineering applications. I feel that additives are also the key to better the environmental impact of polystyrene on the environment. Perhaps by additives or fillers, we can have a polymer that eventually one day breaks down when it comes in contact with long-term UV exposure or even salt water. Only time will tell. And this is my works cited page, and I want to thank you all for listening, and I hope you enjoyed.